Hi, I'm Brian Wood, Application Support Engineer for BenchVue. The free Keysight BenchVue software has revolutionized the ease of use of Keysight instruments by doing the behind-the-scenes work for you of automatically locating and connecting to all instruments it can find on LAN, GPIB, and USB, then giving you a simple way to control them and retrieve data, all without writing a single line of code. In this video, I'm going to show you an exciting new feature that we've added to BenchVue in version 3.0 called Test Flow. It's a flowchart style sequencer that allows you to create automated tests without programming. Let's start with an example without using test flow. Suppose you want to create the modern equivalent of a curve tracer to see the VI characteristics of a transistor as you sweep collector-emitter voltage for several settings of base emitter current and measure the resulting collector current. We'll do this measurement using a Keysight B2962A power source. This instrument has two channels and is capable of low current stimulus down into the femtoamp range and high voltage as high as 210 volts, and it can measure the current and voltage it's outputting with 6.5-digit accuracy. We'll drive the base of a 2N3904 NPN transistor with one channel, set up as a current source, and then apply various voltages to the collector and measure the resulting collector current. No extra components are needed. Let's take a look at how this could be done in BenchVue on a point-by-point basis, manually setting the voltage and current. Here I've already started BenchVue, which automatically discovered our B2962A power source and several other instruments. We will set the voltage limit to 1 volt since we only expect one diode drop or 0.6 volts in the base emitter junction. We will select the 105 microamp current range and we won't enter more than 100 microamps of base current. If the beta of the transistor was, say, 200, 100 microamps of base current would result in 20 milliamps of collector current. But let's select a current limit of 200 milliamps, which is the maximum rating of the transistor. The collector goes to channel 2 of the SMU, which we will set up as a voltage source, which we will manually change from 0 to 4 volts. Okay, the transistor is connected, the parameters are set, so let's turn on both channels. Now let's set the base current to 20 microamps. At 0 volts collector voltage, we are reading basically no collector current. Now let's set the collector voltage at 500 millivolts. The collector current has increased now to 4 milliamps. We can repeat this procedure at 40 microamps of base current, manually recording the numbers and eventually plotting the results. Now let's see how we can automate this procedure using test flow. We'd like to start by making sure the supply outputs are off, so we'll drag the on-off buttons over to the test flow pane and make sure we have selected off. We also want to make sure channel 1 is set up as a current source and channel 2 as a voltage source. Now recall that we want to set the voltage limit on channel 1 to 1 volt and the current limit to 200 milliamps. When we drag these properties over, notice how the flow sequencer defaults to a sweep. In this case, we don't want to sweep these properties, we just want to set them. So we can click the gear icon and select Sweep, Get, Set, or List options. Select Set and OK. We want to initialize the current range to 105 microamps and the voltage range to 21 volts. Now we want to sweep the base current, so we'll drag the current setting property over. We'll set the values in a moment. For each value of base current, we want to sweep the collector voltage, so we can drag that property inside the base current sweep. We'll set its values in a moment as well. We will want a plot of collector current versus collector voltage, so let's drag those measurements over into the inner sweep loop. Notice that we started with the outputs off. We will want to turn them on before we take measurements, so we can right-click on these blocks and select Duplicate. Then we can drag them just prior to our sweeps and turn the outputs on. We also will want to turn them back off at the end, so we can repeat this procedure, placing the blocks at the end. Now let's set the sweep values. We want the base current to go from 20 microamps to 100 microamps in 20 microamp steps. We want the collector voltage to go from 0 to 4 volts in 100 millivolt steps. The minimum available in this case is actually 1 microvolt, so it was changed for us. Now, to make a nice looking plot, we can change the labels of the current source and the collector current and collector voltage to more meaningful names. Our sequence is now done, so let's maximize the test flow window. Let's double check our flow to make sure everything looks good. We can also see a chart and a table where our results will show up. In the table view, the value of the parameters at each step are shown when they change. The chart view gives us a graphical representation of this. We can look at the values as a time-based chart, or we can plot anything against anything else in the XY chart. So let's select the collector current for the y-axis and the collector voltage for the x-axis. Now when we click Start, the familiar shape of a transistor curve trace begins to take shape. When it's done, we can mouse over the chart to see values at each measurement point. Trace data and screenshots can be exported in Excel, Word, MATLAB, and CSV formats. We've shown how to use BenchVue Test Flow and a B2962A power source to make a transistor curve tracer. Thanks for watching.